Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for each function, determine whether the critical point is a local maximum or minimum, and whether or not the tangent is parallel to the horizontal axis. So let's start with critical points. So critical points are points at which the derivative of the function is equal to 0 or undefined. So in this case, we'll have to find the derivative of this function, and then we'll have to find the x values at which the derivative is equal to 0 or undefined. So let's start with the derivative, and that will be prime of h at x equals. Now this is a polynomial function made up of 3 terms, so we'll have to use power rule to find the derivative of these terms. So the first term is negative 6x cubed. So negative 6 is the coefficient, so it will stay as it is, and the derivative of x cubed will be 3x exponent 3 minus 1. So we move the exponent to the front and subtract 1 from the exponent. Now for the second term, 18 is a coefficient, so it will stay as it is. So for x square, we'll use the power rule. So we'll move the exponent 2 to the front and then subtract 1 from 2. Now 3 is a constant, so the derivative is 0 because derivative of a constant is equal to 0. So now we can simplify this expression. So negative 6 times 3 is negative 18, and x squared plus, and then 18 times 2 is equal to 36. So we get 36 x exponent 1, but we don't write 1 as an exponent. Now this derivative expression is a polynomial function, so it won't be undefined for any x value. So we just have to find the x values for which the derivative is equal to 0. So we'll sub in 0 on the left side of this equation. And now we have to solve this equation. So we can do common factoring on the right side. So we can factor out negative 18x. And in the parentheses, we are left with x minus 2, because 36 divided by negative 18 is equal to negative 2. So now we get two cases. So the first case is negative 18x equals 0, and we can divide both sides by negative 18. So the negative 18 on the left side gets cancelled out. So we get x equals 0. So this is the first critical number. Now we can analyze the second case. So x minus 2 equals 0. And now we add 2 to both sides. So the 2's on the left side get cancelled out. So we get x equals 2. So this is the second critical number. Now in order to find the critical points, we have to find the y values for these x values. So for that, we should sub in these x values one by one in the given function. So in the first one, we'll sub in x as 0. So h at 0 is equal to negative 6 times 0 cubed plus 18 times 0 squared plus 3. Now the first two terms become equal to 0. So we are left with just 3. So the first critical point we got is 0, comma 3. Now we can use the second critical number to find the other critical point. So the other critical number we found as x equals 2. We'll sub in x as 2 in the given function. So h at 2 equals negative 6 times 2 cubed plus 18 times 2 square plus 3. And now we have to simplify this expression. So 2 cube is 8 and 6 times 8 is equal to 48. So it will be negative 48. So negative 6 times 8. And then 2 square is 4. And then 18 times 4 is 72 plus 3. And now we can combine these terms. So negative 48 plus 72 plus 3 is equal to 27. So the second critical point is 227. So this function h at x has two critical points. Now we have to find whether the critical point is a local maximum or minimum. So for that we can use the number line method. So we have to find the sign of the prime of h at x on both sides of the critical points, and then we'll figure out whether the point represents a local maximum or minimum. So let's draw the number line. So now we can show the critical numbers on it, which are 0 and 2. So these critical numbers divide the number line into three parts. So the left part is to the left side of 0, and then between 0 and 2, and then to the right side of 2. So now we can use a test value from each part. So for the left part we can use negative 1, and between 0 and 2 we can use 1, and to the right side of 2 we can use 3. So we have to sub in these test values one by one in the prime of h at x to find whether the prime of h at x is positive or negative in that part of the number line. So if prime of hx is less than 0, that means the function is decreasing. And if the prime of h at x is greater than 0, that means the function is increasing. So let's start with x as negative 1. So prime of h at negative 1 equals negative 18 times negative 1 square plus 36 times negative 1. So prime of h at negative 1 equals, so negative 18 times 1 square will be negative 18, because negative 1 square is positive 1. So negative 18, and then 36 times negative 1 is negative 36. So we'll get a negative answer here. So we are only interested in the sign of the value, not the value itself. So that means to the left side of 0, the prime value is negative. That means the function is decreasing on the left side of 0. Now we can analyze the middle part of the number line. So x equals 1. So we sub in x as 1 in the prime function. So prime of h at 1 equals, so negative 18 times 1 square plus 36 times 1. Now we can simplify this expression. So prime of h at 1. So 1 square is 1, and negative 18 times 1 will be negative 18, and then plus 36 times 1, which is 36. So this will be equal to positive 18, which is a positive value. So that means to the right side of 0, the function is increasing because we got a positive value for prime of h at x. Now we can use a third test value. So prime of h at 3. So we get negative 18 times 3 square plus 36 times 3. So a prime of h at 3. So negative 18 times 3 square. So we know 3 square is 9. So negative 18 times 9 is equal to negative 162. And then 36 times 3 is equal to 108. So we get a negative answer for prime of h at 3. So that means the function is decreasing to the right side of 2. So we got a negative value for prime of h. So now we can analyze these results. So for the first critical number x equals 0, so the function is decreasing on the left side of 0 and increasing on the right side of 0. That means there is a local minimum at the critical point 0, 3. Now we can analyze the other critical number x equals 2. Now to the left side of 2, the function is increasing, and to the right side of 2, the function is decreasing. That means there is a local max at the other critical point, which is 227. So we have identified that x equals 0, or the critical point 0, 3 is a local minimum and point 227 is a local maximum. Now, since these two critical points represent local minimum and local maximum, that means the tangent at these extrema are horizontal or parallel to the horizontal axis. So we can conclude, so tangent at critical points are horizontal or parallel to the horizontal axis because these critical points represent local extrema of this function. Extrema of h and x, the given function. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand how to find the critical points and then how to figure out whether the critical points represent local maximum or local minimum. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.